Hello, 3D animation class. It's week 8, and today the topic is physics simulations. At the end of our lecture today, we will also talk about assignment 3. 3? No. Let me look. Assignment 3. You're going to be animating an inanimate object. But first, physics simulations. So this is another kind of bonus fun thing, kind of like the what do you call it? Motion capture data. This is another fun one. That's just kind of a bonus, but it's good to understand because you can really do some creative things with this. So without any more delay, let's go over to Blender. Let's start with the general file. So the basics of a physics simulation is we're using gravity to make things fall and interact with each other. So let's start with our default cube here, and let's GZ slide it up. Let's Shift A, add a plane, scale that up with the S key. And let's also hide our camera and our light just for visibility's sake. So step 1 to doing a physics simulation, let's make this box fall down. So, you can obviously animate the box here at frame 1 and then, GZ move it down and put it there. But why not let math do this for us? So, step 1. We want so a new tab that you maybe have never been on before, it is this one right here, physics properties. It's like the circle with on the smaller circle orbiting around it. The first thing, so this is we're starting with the super basics, and we'll kind of make it more complex as we go. The first thing we want to add to our plane, or let's even rename it to floor, is rigid body. And we now have a rigid body tag on here. And there's two kinds of rigid bodies. There's active and passive. So real quick, so let's leave it as active, and let's go to frame 1 here, or frame 0, whatever, and then press play. Press the space bar and see what happens. Our our floor has fallen to infinity, way down there. That's probably not what we want. So hopefully you can predict that rather than an active rigid body on our floor, we want passive. So this just means it is rigid and it does not move. It's passive. So now if you press the space bar, it stays still. Now you can probably predict what we want to put on our cube here. So let's put a rigid body on our cube and go back to frame 0 and press the spacebar. And the cube fell on top of the plane. Perfect. Now, press the spacebar to stop. I realize I'm peaking just a little bit. Let me turn down my levels. So, looking at your timeline down here, I guess making it bigger doesn't do anything. You can see that there's this, for me, there's this orangish, yellowish bar. And where I stopped it, it changes color, and you can see that there's kind of a lighter colored orangish yellow further along. And this is telling us which part of the simulation has been simulated. So if I drag forward in time here, you can see that it's, I'm not seeing, well, this maybe isn't a great example. Maybe I'll revisit this a little later when we've got more coming on. But the first 150 frames have been simulated here, and the box falls down. Now note that if I'm on like frame 130 here, and I try to G move this box around, it doesn't let me, because it says, nope, you have simulated the position of this, so you got to go back to frame 0 or frame 1 to actually see the change. So now that I move back to frame 0, you can see that this orange line was erased because it says, oh, there's a new simulation now. You need to rerun the simulation. So if I hit the spacebar again, it falls down. Pretty slick. Let me just, whoops, I moved it up and I wasn't on frame 0, so I didn't get to see it happen. Go back to frame 0. Aha, now it moved to that new place. Let's just rotate it a little bit so we can kind of see it fall down a little bit better. Cool. Nice. Let's have fun with this a little bit. So let me delete this. Actually, no. No, let's. I'm thinking like 10 steps ahead. Okay, let's leave this here. This seems like a good spot. Oh, you know what? Okay, I'm thinking of more things. Let's set this back to, I want location X to be 0, location Y to be 0, and I want this to be 0, 0, 0 for rotation. And I'm on frame 0 here. And I'm going to simulate this and let it kind of hit the ground right there, perfect, and then stop. Now, I know that this is like resting right on top of it, and I actually want to keep this right here because what I want to do is I want to make like a little like teeter-totter catapult situation and see what we can do with that. So I don't want to have this fall down on the floor every time I want to do my physics simulation, so I'm just going to apply its current position. So right now I'm going to go to Object and apply location, or apply all transforms really is. Hold on. Oh, that was the wrong. Well, what am I doing here? That was the wrong apply. So let's see. I want this to fall. I was in the wrong menu. So we do go to Object, but rather than apply, we go to Rigid Body, and then Apply Transformation. Okay. So now it's just beginning here. So it's just sitting right here. It's still part of our. Sorry, I'm peeking a little bit. It's still part of our physics simulation. It still has the rigid body on it, but it's just like we've moved it to where it landed. Okay, let's also let's go to Tab Edit Mode, and I wanna move these two. Let's see, 2 for edge select. I'm gonna hold on to these 2, and I'm gonna SX scale these together like this. So we're gonna make like a little fulcrum. Okay. Now, Shift A, let's add a new cube. GZ, move it up like this. SX, scale the Y. SZ, scale it down so it's kind of flat like this. Let's also just make it a little smaller maybe. Okay. And let's go to our Physics tab here, and let's add a rigid body to this. Active. So now this just kind of falls into place there, right? Yeah, okay, great. So what I'm thinking here is we got to put something on the end, and then we got to drop something heavy on the top here. So let's see. Let's also, you know what? Maybe we should just make our fulcrum passive too, because that'll be a little easier. This is going to be active. Great. That all looks good. Now let's think of something to put on the end here. Let's put a donut on the end. A torus. Sure. GZ. Whoops, and did I think I forgot to apply the transformation for this. So let's go to Object, Rigid Body, Apply Transformation like this. Okay, there we go. G, Shift, Y to move our donut right here. Let's give that a rigid body too. And it just kind of sits right on the end there. Great. I'm going to just move it a little bit more because I kind of want to like flip. Oops, got to go back to frame 0. Apply there we go. And then on our donut, we also want to apply rigid body. And apply transformation. Okay. So right now we've got, whoops, I did edit mode. Didn't mean to do that. Object mode, please. There we go. So we're on frame 0. I press the space bar. Nothing's happening. So now we need to drop something on the other end here. Let's do it. Shift A. Add a UV sphere. No, better yet. No. We should do a UV sphere. We should do UV sphere. G, Shift X. Oops, no, Shift Y. Move it up here. So it's above. It's going to be falling straight down. Add a rigid body. It's active. Okay, here we go. I'm on frame 0. I'm going to press the space bar. Nice. Cool. We did it. Scale that up a little bit. Let's try it again. I don't want it to fall off into oblivion. Okay, now one thing you may be noticing is like, it feels a little slow. Like I feel like I want it to kind of be dropping and happening faster. So we need to go to our no, which one is it here? Is it scene collection? Or is it, no, here, scene properties. Here we go. It's this one, the little shape. And we have rigid body world. So you can see there's actually is gravity, a gravity setting in here. You can alter the gravity, or you can have gravity moving in different directions. But negative 0.98 meters per second squared is Earth's gravity. Rigid body world. This is the one. So here we is a little speed thing, and you can up the speed here. So if I make this 2, so it's happening a little faster. So actually, and you can see that it's maybe not quite keeping up with my processing speed too. So this also impacts kind of, or like, you'll see the effect of the speed in your render. Frame range. Okay, cool. What else was I gonna do here? I was gonna change the frame rate. I was just gonna change this to 30 frames, so it's like a little smoother. So the speed of 2 maybe seemed like a little bit too fast to me. So maybe I'll make it 1.5. No, 1.75. Go back to frame 0. I don't know. Maybe 2 is right. 1.8. 1.85. This doesn't matter. Cool. All right, that feels good. All right, so I want this to like flip a little higher. I wanna see this. I want this to, you know, shoot up a little higher. So hopefully you have a basic understanding of physics as well. But there's a couple ways you can put more force down on here. The first way is to just increase how far this is falling. That creates a little bit more force. Or you can also increase the weight of this. So there are weight properties in here. So if we go back to our physics properties, you can change in rigid body, you can change the weight of this. So this is 1 kilogram. You can make it 5 kilograms. See what this does. Now, see, now we're really going crazy. Cool. This feels good. Oof, I like that our fulcrum also just kind of gets smashed too. Hi. Okay. All right. So this feels pretty good. Let's say I wanted to like watch this fall a little bit further. You can see that our thing only goes to 250 frames. You can change this, to 500 frames, but actually the simulation doesn't go any further than 250 frames because there's an additional setting that you need to change. So you can see my orange line still only goes to 250 here, and then it freezes. You can see our torus is frozen down there. And that is back in our scene properties. Under rigid body world, I think it's in cache here, yes. Simulation start, simulation end. So even though our scene is 500 frames long, the end here is 250, so you can also make this 500. So now there's 500 frames of simulating that happens, so then it will continue to fall forever. Okay. That's that. Next thing, let's talk about collisions just a little bit. So I want to make like a little box for this to catch this flying donut. So let's model one. So Shift A, I want to add a cube. That's G, Shift Y, move it over here. I also, let's see, if I play this, I want to make sure that I'm getting this in the right spot. So I can step through my animation here and say like, okay, yes, this is the place where I need to catch it. So like, whoops, right about here. Okay, so I'm gonna move my box into the right spot here. Tab for edit mode. And 3 for face select. Grab the top one. I'm going to I insert faces, and then I'm going to E extrude down, please, like this. So this is our little catch box. So let's make sure that this goes in. And then back into object mode, and then we need to just tag a little rigid body on here. Great. And it's passive because we don't want this to fall down. Okay, let's just check this out. Oh, interesting. It landed on the top rather than going inside. So this has to do with the collision. So we've got, what is this cube? Okay, I gotta name things. This is the lever, and this is our basket. Okay, so on our basket we have rigid body, passive, but under collisions, convex hull. So actually hovering over this, it says a convex hull is a mesh-like surface encompassing all vertices. So this actually means like it's kind of wrapped around the outside. So the one we want here is mesh. This is mesh consisting of triangles only allowed for more detailed interactions than convex hulls. So like those of you that play video games are maybe familiar with collision boxes. That like a lot of times in games and in other things, if you have like a physics game or a physics-based game, or even like a shooter game, you have like a hit box, like the area in which your character is hit. So like a lot of times, or in earlier games, it was just like a box. So like it may be goofy and you may feel like your character wasn't getting hit with the sword because it was like just nearby, but that because the hit box was different than the actual like mesh of the character, your character would take damage from the sword even though it like was a near miss. But anyway, so convex hull, we can change this to mesh, and so this actually makes the whole mesh, each polygon is part of the hitbox. So I believe now this should just fall right in. Yes, there we go. The donut is in the basket. Nice. Very nice. Cool. Okay. Now let's let's talk about another thing we can do. So animation. Sorry, I'm just watching this again. I want to add something in here that kind of bumps, like a little hammer that bumps the donut out of the way. So it sort of like denies the shot a little bit. So I want to pause this like maybe like right here. Because remember in basketball, you can only block the shot if it's before the apex of the ball's arc. So like right here. Okay, so let's just put a little like hammer in here. I'm gonna do a cylinder, and just scale it up, and actually that's fine where it is. Okay, and let's RX90. I just want to make sure I'm getting this lined up. So I want it to be right here, and do my top view like this. Actually, so at this point, I want it to be like hitting it like this. Okay. And then I'm going to keyframe this. So I'm just going to turn on auto key, and I'm going to do I key location like this. Okay. And then I'm going to move back a few frames, and I'm going to GY, just move this like this, and it's going to auto key. And I also want to make these just like, it's just like a straight up vector. I don't want it to ease. And actually I'm probably going to move, oops. I want to move this keyframe a little bit closer so it moves faster. Okay. And then we need to do rigid body because we want it to interact with this. It's passive, so we can hit passive here, but we also need to make sure that it's animated. So it allows the rigid body to be controlled by the animation system. So like it has keyframes on it. So we got to tick animated so that it actually moves with it here like this. Okay, let's go to frame 0. Let's play this. Let's see what happens. Let's see if it gets denied. Yes. So let's play it again. Boom. Denied. Cool. And now we should be able to play this back. Yeah. Oh, for whatever reason, when it didn't save my animation. There we go. Let's get a close-up view of this. Hey, boom. Very good. Okay, so that's rigid bodies. You can have some fun with this. But let's talk about like bounciness and soft bodies and cloth a little bit. So I'm gonna delete all of these things. Delete. Actually, hold on. No, before I do that. Okay, didn't delete everything. Let's let that play. So let's say you're pleased with this animation. You do have the option to then like keyframe all of this. So like have it not have it actually be a simulation every time, but actually like make it official. So this shows my age a little bit. Facebook was really big when I was younger, and you used to like have relationship status, and you could like say that you were in a relationship with someone, and you would say you'd make it Facebook official, and it like became a meme that was like, make it Facebook official, because if it's Facebook official, then it's real. Anyway, it's dumb. I'm sorry. Okay. So right now it's always just simulating the physics. So let's, like, if I go to, it's simulated up to frame 195 there. If we go back to our scene properties here, remember cache is where we changed the simulation start and end. This is also where we change the speed. There's a button here that says bake physics. And if you hit this, what it does is it like removes all of the like rigid body stuff from, well, no, I shouldn't say it doesn't remove it, but it, let's see. What did it do? Oh, sorry. So it was the wrong bake. So rather, I keep going to the wrong menus today. So, and you do it on a per object basis. So, like our donut, for example, it's here in the object menu. So if I go to object, rigid body, and here it is, bake to keyframes. And you can choose how many frames or how many frames out you want it to bake, but you can hit OK. And then now you can see down here on my timeline, it is now filled with keyframes. And what even happened? Why is my sphere there? Did I have both of those selected? Undo, undo, undo. Why did that go with it? If I do this, right click, or if I go object, rigid body, bake to keyframes. Okay. Huh, interesting. I wonder why that did that. Oh, you know what? It's because, no. Strange. I'm not sure why this is happening. What if I delete this bake? Because this is still being impacted by that sphere. Let me remove the rigid body real quick. Oops, and let me delete all bakes like this. Delete all bakes. So strange. It just zips over there. Let's figure this out. Let me remove the rigid body. Get rid of rigid body. So yeah, that's still happening. Okay. Let's reapply this rigid body active. There we go. Except now it's like the timing is off. There we go. That time it did it. That was strange. I don't know what the deal was. I just removed the rigid body and took it off again. But anyway, okay. So now you can see, because we baked the keyframes on just the donut, it removed the rigid body for here, and it just has all of these keyframes baked in here. So you can see here under the summary that object transform, like you can see all of the rotations and stuff that's happening. You can go in and tweak these if you want. But again, this is something that you would only do at the very end, if you so chose. It's perfectly fine to just leave it as a simulation. and then bake the simulation. Anyway, okay. So that's it. That's enough for rigid bodies. Let's talk about soft bodies a little bit. So I'm going to delete all these, Okay. Let's add a sphere back in here, GZ. And let's add a soft body for this. Sorry, remove rigid body. Actually, before I even talk about soft body, let's actually do a rigid body, and let's talk about the bounciness of it. So, oops, and I want to remove auto key and delete these keyframes. So, by default, I just have, this is the regular rigid body. It just sort of clunks down there. There's like a little bit of bounce. You can change the under surface response, you can change the bounciness of it a little bit. So like if I up the bounciness to 0.5, this is on the ball. You can see not a lot is happening there. If I up the bounciness on the floor, go back to frame 0, you can see it's starting to get a little bit more bouncy. So in combination, you can make things a little bit like bouncier. So now this is full bounciness on both the ball and the floor, but it's still like a little bit goofy, which is why we should maybe look at soft bodies. So let me just like Shift D, Shift D, Shift D, Shift D, like this. Okay, sorry. Okay, delete all these. Shift A, let's add a new UV sphere, GZ. Let's add a, rather than a rigid body, let's add a soft body to this. Okay. If I go to frame 0 and play with a soft body, you can see that it's actually just kind of like hovering right here. And that's because the like default state of a soft body is to like to stay in its own place. So like real quick, if I just as a experiment here, I'm going to go to like frame 11, and I'm going to keyframe this cylinder here. I'm going to go like here, and I'm going to have it like bump it like this. Oh shoot, and I got to move back. Boom. And I want to move back again like this. So just want this to like hit it. We need to give this a collision. Let's see what that does. Okay, here we go. So collision. Rather than a rigid body, the our little mallet here needs a collision. So how collision and like rigid body are sort of similar, but like you use collision when it's more of a dynamic interaction. So like cloth needs collision if it's interacting with something else, and soft bodies need collision when it's interacting with or something that's interacting with cloth or something that's interacting with the soft body needs to have the collision tag on it. Anyway, so you can kind of see, and it like really slows down, but like when this thing bumps into it, it like jiggles it, you know? And so there's a couple things that we can do. So that's just an example of that. I'm actually going to delete this. On our sphere, the first thing I want to change is goal. And so the goal means like it is trying to keep its shape. Its goal is to keep its shape. If I hover over this, what does it say? Whoops. Define forces for vertices to stick to animated position. But if we uncheck goal, this will just like fall to the ground and collapse. And actually, you'll see that it just fell straight through our floor here. And that's because our floor needs collision. So that's kind of just reinforcing my point from before, that because we want the floor to interact with the soft body, it needs collision. Okay, here we go. So our ball falls onto the floor and just like totally collapses. So we got to change our sphere settings a little bit. Let's see. Cache, where is it? Oh, it's in edges here. Whoops, soft body. Close object, close simulation, close cache. It's in edges. So the bending, this determines like how stiff it is. So bending is on a scale from 0 to 10. If we turn it up to 10 now, I believe it should just... Oh yeah, so it does kind of like jiggle a little bit, but it does stay pretty stiff. Okay, great. Plasticity. Let's hover over this one. Permanent deform. So did it? Oh, okay. Push and pull. I think so. I think if these go all the way up. What? Oh, where did it go? Did it go up to infinity? It just disappeared. Hold on. All right, here we go. So 0.999 was too much for the pull and push. 0.9 is better. So this is like how much force there is. It's sort of like bounciness when things are getting deformed. So 0.9 with 10 bending here, and actually the edge spring action is also impacted by the damp here. So actually, if you crank this way up to 50 is as high as it goes, I believe that it's just, oh yeah, it's still about the same. If I turn damp back to 0. So you can see the soft body situation requires a little bit more computing power. You can see my FPS going down here because it's trying to figure all this out. Okay. So plasticity here, plasticity is 0. So if you turn this up, this is like permanent deformation of it. So it's sort of like, you can see that, and actually maybe a better thing to show here is if I put a cube in here and I place it like right underneath here like this and add collision. This is going to land right on the corner. Let me turn off auto keying, delete those keyframes, please. Thank you. So if I play this, it's going to hit that corner, chunk, and get deformed. Oh no, did I change that? Did I not change that setting? Here. Oh yeah, plasticity. So if I turn up the plasticity like this, and then have this hit the corner, there's going to be a permanent dent in it. Yeah, you can see it there. And then when it hit the ground too, there's kind of a little flat spot where it hit. So that's what the plasticity does. Permanent deformation of stuff. Okay, so that's kind of what soft bodies can do. Obviously, if we turn goal back on, it's gonna like hover there a little bit. But we can do the same thing we did with the cube. We can I insert keyframes here, location, move forward in time, have it kind of hit in the corner there like that. I available, and then G move it back like, oops, move forward in time, G move it like this. I available. So now it's gonna like bump into it a little bit. Kind of hits it. It gets stuck a little bit. But now there's a little dent in it. You can do it a little faster. Cool. Okay, let's talk about cloth. Okay, so deleted those things. Let's shift A. Let's add a new UV sphere. GZ. And we're going to give this one collision because we're going to have it interact with cloth. And we're going to put it, like, drape a cloth over top of this. So shift A. Let's add a new plane. GZ S to scale it up. Okay. So right now in our simulation, nothing is happening. So if I stick cloth onto this plane right now and go to frame 0, it's just going to land on top of this and just sit there. And that's because the cloth tag takes the existing geometry and kind of folds it around. So right now this plane is just one square. So there's like no parts where it can bend. It can only bend on edges. So let's try putting on a subdivision surface modifier. and see what that does. We'll put it above the cloth. Aha, so it is starting to bend a little bit. Let's up the levels. Whoops, it kind of got a little borked there. Ah, okay, it's starting to look a little bit better. Let's go back to frame 0. Let's scale this up and have it subdivide even more. 4. Aha, it's starting to feel a little bit more clothy. Ultimately, I want it to like hang on there. But let's go to our physics tab. Let's change the let's actually go even more. Let's go 5 levels like this. Back to frame 0. Here we go. This is feeling a little better. Yes. And let's right click shade smooth. Okay. Cool. Okay. On our physics tab, let's do I mean, you can change all this. The stiffness, the shear, the bending. So like you can up the bending, turn down the tension and the compression like this. Let's see what this does. Aha. Yeah, that's feeling nice. Quality steps. Maybe turn up the quality steps. Make this 7. See what this does. Maybe also up the subdivide a little bit more, and maybe it's 6 levels. So now we've got a little bit more detail in it. Ah, oh, it's looking like the real thing now. One thing that you're probably seeing is that it's like passing through itself a little bit. So let's look at the collisions. Let's go down to collisions like this. And turn on self collisions and see what this looks like. This will hopefully help us a little bit. You can see that this is also kind of slowing down the computer a little bit. But this is looking really nice because it kind of hits itself a little bit, and that's really good. And so one thing you can maybe do is once this is like in its spot, you can let's see, bake. Well, and that actually maybe doesn't quite work with this anyway. And so talking about speed, so just kind of thinking about how like slowly this was moving down. And I forgot to mention this with the soft bodies too, but the speed, remember how we changed the speed of the rigid body world? With soft bodies and with cloth, it actually, each thing has its own speed property. So you'll kind of just have to keep track here. So right under cloth here, speed multiplier. So we can do like 1.85, I think is how we had the other one before. It felt like a pretty good clip. Obviously, like now it's going to look a little, my speed is slow anyway. You can see it's only 7 frames per second up here, but in your render, it'll happen faster. The other thing too, now that we can do is we can take our sphere and we can like keyframe it, I, location, and then like I, location, there we go. Move forward in our timeline, and G, like move it over here. I, insert location, keyframe again. And that now when we simulate this again, it'll follow the sphere with it. It'll kind of move with it. And I probably should have made these keyframes a little closer to the beginning so we didn't have to wait for it. Oh, and there it goes. So like this is your spooky Halloween ghost for today. Ah, but look, it fell off. Okay, so to fix that, we need to increase the quality of the collision. So like it's only calculating the collisions like every so frequently and every so like with enough detail. So because this was moving away, it was like, oh, you went away. Oh well, we just are falling. Also, this is interacting with the floor because remember we also put a collision on the floor. So anyway, what we can do on our cloth, go back to frame 0. Here in our physics properties under collisions, we have quality. So this says how many collision iterations should be done. Higher is better quality, but slower. So you can up this to just like 4 maybe, and let's see how this does. So it's landing on the ball, and I should have moved these in a little closer. But let's see how this does. It's moving slow, 7 frames per second. All right, it seems like it's hanging on a little bit. There's our spooky Halloween ghost. Very cool. So then, like, to combine our like things a little bit, let's go back to frame 0 here. I'm gonna GZ move this up. Let's Shift A, add a cube. S, scale this up. GZ, move it like this. Let's tab 3 for face select. I insert faces. E extrude down like that. Tab to get back into object mode. Let's GZ move this up a little bit. Let's give this collision and a rigid body. And just play this so that sits there. I also, okay, so hold on. Oops, I forgot to. So hold on, I'm doing 2 things at once here. So I'm gonna apply the transformation for our rigid body. Let's move our sphere up and actually remove the keyframes for this because we're not animating it. I don't want to animate it anymore. I'm gonna GZ move that up. That has, we want this to be rigid body as well. Is this going to work the way I think it is? Okay, and we got to change the collision. We got to change the collision on our cube. So back on our rigid body, we want this to be. We want this to be mesh. Here we go. Let's try this. Wait, whoa, hold on. I forgot we changed the bounciness of the ground. Did I change the bounciness of this? Rigid body. We don't, oh yeah, bounciness all the way down to 0. Bounciness all the way down to 0 here. Let's try this. Hold on. Is it maybe I'm doing too much here. Maybe this isn't going to work the way I think it is. Let's remove the rigid body. Oh no, shoot, I did the floor. We do want that on the floor. Let's remove rigid body here like this. Passive on the floor, here we go. Oh, okay, so can you see what I'm trying to do here? I'm trying to get the ball, I want the ball to land, so we can, I like how it's interacting with the cube, that's good. But I want the ball to go in and push down. Where's my ball? The ball to go in and push down the cloth. Okay, hold on. So here's a cool thing I found. I follow this this Instagram account called Motion Graphics Collective. But like they've got maybe not in this class, maybe actually in the modding class we'll talk about like fluid and smoke. No, actually I think we are going to do it in this class. But like, you know, they've got these conveyor belts moving, and then like I guarantee you that they just use physics to have these things laying on top of it. So like you don't animate, you know, every single one of these things. You just have them like solid, rigid bodied into like a little thing and have them sit on top of a conveyor belt, and then all you do is you animate the conveyor belt, and these things just go along with it. So that's one cool thing. I saw this other thing. It was just kind of simple, but it's like, you know, things falling into place and spinning and gears that kind of interact with each other. That these are, well, maybe not these things particularly, but you can use physics to do kind of some cool animation stuff. But then this is kind of a trendy thing that I think I see motion designers doing, is creating sort of like these Rube Goldberg machines, that it's sort of like things that loop infinitely, but it's like, you know, this interacts with that and it hits that and it presses a button and then it goes around, and just, you know, things like this. Kind of some cool, just designy things that people do with physics simulations. Okay, let's talk about assignment 3. Okay, here we go. Assignment 3, inanimate objects. Animate any inanimate objects to tell a very short story. Not less than 10 seconds. At least 10 seconds. At least 10 seconds. But it doesn't have to be more than 10. So, like, do the math. If if you're doing 30 frames per second, it's 300 frames. You can create your own models if you wish, or find free models on the internet. At least 2 objects in your scene must be animated. One of them could be your camera. Be creative. Have a beginning, middle, and end. Use different camera shots, and then render out your finished product. So this is worth 15 points. 10 points are for having at least 2 objects animated to tell a story. 3 points for having at least 10 seconds of video submitted and uploaded to D2L as a video file, and then 2 points for an on-time submission. So definitely don't go crazy trying to find or create models. Lots of free models here in at Polyhaven. So just looking at what they got here, like maybe you've got this wooden elephant that jumps up onto a barrel and then a clock flies in and knocks it off the barrel. I don't know. But like, you know, we're doing this because I want you to practice animating and not have to worry about characters and rigs and armatures and stuff like that. So like, it can be silly, it can be goofy, but just like, you know, find some free models if you want, or create your own models and just tell a simple story. Be creative. And then I'd like a video file. So like maybe this kiwi falls into a chair, and then the drill comes over and drills a hole in it. I don't know. There's some cool models on here. So yeah, and you can sort. There's like furniture, industrial, electronics. I don't know. Or like use any other free model website that you wish. So next week is MEA. So you don't have. Let me just go to a white page here so I'm lit up a little better. Next week is MEA. So we don't have a lecture or anything going on next week. But just we've got assignments coming in here. So make sure that you're finishing your assignment 2. So your assignment 2 is going to be due on the 27th. That's the face animation, and then assignment 3 we're going to have due after that. So again, like the more important thing here with these assignments is just to finish them. They don't have to be crazy or super detailed. As you hopefully have noted from my grading scheme, I'm not grading you on how good it looks. And to me, they all look good. So you're getting the points. The key is to just get it done. So we don't have any class or any lecture or anything next week, so that's an opportunity to kind of maybe get caught up if you're falling behind. So yeah, nothing next week. Thanks for hanging out, and good luck. Email me if you have questions. So long.